our next section, which is the practical session. Yeah, but again, let's finish up with the lecture, and then we can go for checking your practical questions and your assignment. Okay, so let's just start now. Okay, for the next topic is on recursion, the types of recursion. So we're gonna listen to this video first. Yeah, it's very informative. Just hang on a sec.
In this lecture, we will continue with our discussion on different types of recursion. So let's get started. As we already know, we have 4 types of recursion. The first one is direct recursion, second one is indirect recursion, third one is
We shall go for tail and the next 3 and 4 first. Yeah, later on we'll go for direct and indirect.
tail recursion and fourth one is non-tail recursion. In the previous lecture, we have already talked about direct recursion and indirect recursion. Now in this lecture, we will try to understand what is tail recursion and what is non-tail recursion. So let's get started. What is tail recursion? A recursive function is said to be tail recursive if the recursive call is the last thing done by the function. There is no need to keep record of the and as you can see inside this function, we have one if construct and else construct, right? Now if you observe this code carefully, you can see this is a recursive program, right? As we are calling this fun function again within this function only. But this is a tail recursive program. Why this is a tail recursive? Let's see the definition. If the recursive call is the last thing done by the function, please highlight this line. If the recursive call is the last thing done by the function, this is the recursive call and this is the last thing done by the function, because after this recursive In this lecture, we will continue with our discussion on different types of definition. If you observe this code carefully, there is no need to keep record of the previous state. Let's try to understand this definition with the help of an example. Suppose we have this code, and as you can see inside this function, we have one if construct and else construct, right? Now if you observe this code carefully, you can see this is a recursive program, right? As we are calling this fun function again within this function only. But this is a tail recursive program. Why this is a tail recursive? Let's see the definition. if the recursive call is the last thing done by the function. Please highlight this line. If the recursive call is the last thing done by the function. This is the recursive call, and this is the last thing done by the function, because after this recursive call, you didn't find anything to evaluate, right? That is why it is the last thing done by the function. So this is a tail recursive program. Now what does this line mean? There is no need to keep record of the previous state. We can understand this line better by considering our traditional method, that is by representing a stack and then evaluate this whole program. Let's say we have the stack, and as we already know, the execution starts from the main function. Therefore, main function activation record will be stored inside the stack. Now, inside this main function, you are calling fun3, which means now the control will transfer from main function to fun3, right? 3 means n is equals to 3. As 3 value is passed to this n, therefore n now contains value 3. And the activation record of this function will get stored inside the stack. Inside this function, we have an if construct which says if n is equals to 0, then you should simply return. But as you can see, n is equals to 3, therefore this condition is not satisfied and we land at this point. That means we will evaluate the else part. And inside this else part, you can see we have a printf function which will simply print the value of n on the screen. This means as n is equals to 3, value 3 will get printed on the screen, right? After this printf function, you can see we have one statement, return fun n minus 1. This means we will simply call fun2. Now as we know, the control will transfer from fun3 to fun2. The activation record of this function will get stored inside the stack, correct? As n is equals to 2, therefore this condition is not satisfied and we land here in the else part, and we will call printf function and we'll simply print the n value on the screen, which is 2, right? Again we call the fun function, but this time value of n will be 1. Therefore the control will transfer from fun2 to fun1 and the activation record of this function will be stored inside the stack. Now n is equals to 1, again the condition is not satisfied. The else part will get evaluated, and in this case we will call printf function and we will print 1 on the screen because n is equals to 1, right? And then after that we again call the fun function with the value of n equals to 0. This means the control will transfer from fun1 to fun0 and the activation record of this function will get stored inside the stack. Here, as you can see, n is equals to 0, right? As 0 is equals to 0, therefore the condition is satisfied and we will simply return back to the previous function. We will simply return back to the previous function. That means we have to return at this particular point. This means the activation record of this function will get popped out of the stack and we'll come back to fun1 at this point. As we know in the tail recursive programs, recursive call is the last thing done by the function. This means after this, there is nothing to evaluate. So what we are doing here? We are simply returning back, right? We have to do nothing after this recursive call. Let me tell you one important application of stack, that whenever we are calling a function and when we return back, we are assuming that there is something that needs to be evaluated. But here, as you can see, when we are returning back, there is nothing to be evaluated. That is why we are saying there is no need to keep record of the previous state. Why you're maintaining the record of the previous state? Because when you return back, there is something that needs to be evaluated. There is something left off that needs to be evaluated. But here, there is nothing to be evaluated. That is why we are simply returning. And hence we can say that tail recursive functions are not utilizing the properties of stack properly. That is why when we are returning back, there is nothing to evaluate, and hence there is no need to keep record of the previous state. We are just returning back, right? After calling the function. So here also we simply return back to fun2. And as usually we land at this point, and after this there is nothing to evaluate. So we simply return back to fun3. And then again we return back to main function, and finally main function activation record will get popped out of the stack. And the output is 3, 2, 1. Now, let's try to understand what is non-tail recursive function. A recursive function is said to be non-tail recursive if the recursive call is not the last thing done by the function. This is just opposite of tail recursion, right? After returning back, there is something left to evaluate. Very important to understand. Let's consider one example. Here you can see after this function calling, we have something to evaluate. This is very important. And here, as you can see, the recursive call is not the last thing done by this function. Now let's try to understand this code with the help of a stack. Suppose this is our stack and the execution starts from the main function. Therefore, the activation record of main function will be stored inside the stack. Now here we are calling fun3. That means the control will transfer from main to fun3, right? And the activation record of this function will get stored inside the stack. As 3 is not equals to 0, condition is not satisfied, we will call fun2. Therefore, the control will transfer from fun3 to fun2. And the activation record of this function will get stored inside the stack. Again, 2 is not equals to 0, condition is not satisfied. Therefore, we need to call fun1. Control transfers from fun2 to fun1. And again, the activation record of this function will get stored inside the stack. Now again, 1 is not equals to 0, we call fun0. Now in this case, as you can see, 0 is equals to 0. Therefore, we will return back, right? We'll return back to fun1. This means activation record of fun0 will get popped out of the stack. Now we are here at fun1. That means at this particular point. After this, we need to evaluate the statement. That is why it is not a tail recursive program. It is non-tail recursive. And what we need to do is, we need to print the value of n onto the screen, which is equals to 1. Because n is equals to 1, right? And then after that, this function activation record will get popped out of the stack. And now we are in fun2, which means at this particular point in time. And as n is equals to 2, 2 will get printed on the screen, right? And then again, the activation record of this function will get popped out of the stack. And as we know, what is going to be the next output? 3, because n is equals to 3 and we need to print the value of n. And then we pop this activation record out of the stack. And now we are in the main function. After this function evaluation, we simply have to return. Therefore, the activation record of this function will also get popped out of the stack. And this is our final output, which is 1, 2, 3. If you see in comparison with the previous function, the output is just opposite of that. Previously, the output was 3, 2, 1, and now it is 1, 2, and 3. Correct? This is all about tail recursive and non-tail recursive. But it will be better if I consider one more example of non-tail recursive program. So let's dive into one more example. Now here is our example, and this is a non-tail recursive function. Please note down. Now why it is non-tail recursive? You can see over here there is one statement, return 1 plus fun of n by 2. You might think of this function as tail recursive, right? Because you may think like, after this function calling, there is nothing to be evaluated. But my dear friend, let me tell you one thing. After returning back, this function definitely returns some value, and this value will get added to this value 1. Which means after returning back, we need to evaluate this addition. We need to add value 1 to the value returned by this function. Okay? So that is why this is a non-tail recursive function, and please don't confuse this with tail recursive. Now let's try to understand this program with the help of a stack. Here is our stack, and as the execution starts from the main function, therefore the activation record of main function will be maintained inside the stack. And inside this main function, you can see we are calling printf function, and inside this printf function, we are calling fun function, and we are passing 8 value to the variable n as well, right? So whatever the value will be returned by the fun function will be printed on the screen with the help of printf function, right? Okay, so now as we know, the control transfers from main function to fun function. Therefore, the activation record of this function will be maintained inside the stack. And as n is equals to 8 and 8 is not equals to 1, therefore the condition is not satisfied, and hence the else part will get evaluated, right? And inside this else part, we have one statement, return 1 plus fun of n by 2. As n is equals to 8, 8 divided by 2 is equals to 4, right? Therefore, fun4 will be called, and hence the control transfers from fun8 to fun4. And the activation record of this function will be maintained inside the stack. Now as n is equals to 4 and 4 is not equals to 1 again, the else part will be evaluated. And here we are calling fun of 2 because n is equals to 4 and 4 divided by 2 is 2. Therefore, the control will transfer from fun4 to fun2 and the activation record of it will be maintained inside the stack. In this case, n is equals to 2 and 2 is not equals to 1. Again, else part will get evaluated. And hence we are calling fun of 1 because n is equals to 2 and 2 divided by 2 is equals to 1. Now as n is equals to 1 and 1 is equals to 1, this condition is satisfied. Therefore, we will simply return back but with the value 0. And hence the activation record of this function will get popped out of the stack, right? And we return back to fun2 at this particular point. As the value 0 is returned by fun1, therefore this will get replaced by 0 and 1 plus 0 is equals to 1, right? And we will simply return 1 back to the fun4. That means at this point, now this will get replaced by 1 and 1 plus 1 is equals to 2. We will simply return 2 back to this particular function, right? This means we land again at this point. Now as this will get replaced by 2 and 2 plus 1 is equals to 3, we will return this value back to the main function. That means at this particular point. So this will get replaced by 3 and hence the output will be 3. After this, the main function will get popped out of the stack. Hence our final output is 3. This is what is printed by this function printf, right? Now I hope after considering this example, everything is clear about the non-tail recursive functions. Let's dive into our today's homework problem. Identify whether the following programs are tail recursive or non-tail recursive. You have a program 1 and program 2. You need to identify which program is tail recursive program and which program is non-tail recursive program. Okay friends, this is it for now. Thank you for watching this presentation.
Okay, that is tail and non-tail recursion. Is it clear? I think it's clear, yeah?
Oh, yeah.
Simple. Yeah, okay. Next, this is the elaboration of what had just happened in the video. This one first. Okay, tail recursion occurs when the last action performed by a recursive method is a recursive call. Okay, so in the video it says your function gets called and the last. So in this example, this is your method being called. Okay, so this performs a method. Straightforward usually, right? Repetition that can be done more efficiently with iteration. So this is basically an example of iteration. Conversion to iterative. Next one, tail. Okay, the tail recursion simply repeats the method's logic with changes to statements. Okay, perform the same repetition by using iteration. Replace the if statement with a while statement. Replace the recursive call with a statement to update the parameter. So this is your sample code for tail recursion. Yeah, okay. So next one is when you already confirmed with this one, we go straight to your direct or indirect recursion. Just now was a tail and untail, now direct and indirect. Okay, or you call it mutual exclusion.
In this presentation, we will try to understand different types of recursion. So let's get started. There are basically 4 types of recursion. First one is direct recursion. The second one is indirect recursion. The third one is tail recursion. And the fourth one is non-tail recursion. In this particular presentation, we will discuss the first 2 types, that is direct recursion and indirect recursion. Now let's try to understand what is direct recursion. A function is called direct recursive if it calls the same function again. What does it really mean? Here is the structure of direct recursion. Suppose you have a function fun, and inside this function you are calling this function again. This is called direct recursive. Whatever the programs we have encountered in the previous lectures are all direct recursive programs. Right? Direct recursion is simple to understand, but what is indirect recursion? A function, let's say fun, is called indirect recursive if it calls another function, let's say fun2, and then fun2 calls fun again, directly or indirectly. What does it really mean? Let's say we have a function fun, and inside this function you're not calling this function, but you're calling another function, let's say fun2, whose definition is available over here. And inside this function, you are calling fun function. If you observe this code structure carefully, you are calling function fun only, right? This is a recursion for sure. But you're calling this function indirectly, right? You're first calling fun2, and then from fun2 you're calling fun function. This is called indirect recursion. Okay, let me repeat the definition for you. A function, let's say fun, is called indirect recursive if it calls another function, let's say fun2, and then fun2 calls fun directly or indirectly, right? I know it will be a little bit difficult for you to understand the concept behind indirect recursion, and you want to know where indirect recursion is useful. So to address all these doubts, let me give you one program which will help you to understand indirect recursion in better details. Write a program. This is the short form of writing. Write a program. Write a program to print numbers from 1 to 10 in such a way that when number is odd, add 1. And when number is even, subtract 1. You want this program to produce an output something like this. When you encounter an odd number, you should add 1 to it. And when you encounter an even number, you should subtract 1 from it. That's what we have to do, right? And we have numbers from 1 to 10. As we have numbers from 1 to 10, so 1 becomes 2 because the number 1 is odd, right? After that, you encounter number 2. As number 2 is even, therefore we need to subtract 1 from it, so it becomes 1, right? And then after that, we encounter 3. As 3 is an odd number, we have to add 1 to it, so it becomes 4. And then we encounter number 4, which is an even number, so we should subtract 1 from it, so it becomes 3. This is how we need to progress, okay? And this is the output we are expecting. Let's see how we can code this particular program to produce an output something like this. Suppose we have two functions, odd and even. As the name itself suggests, odd function will handle odd numbers and even function will handle even numbers. Whenever an odd number is encountered, it will add 1 to it and print it on the screen. And when an even number is encountered, it will subtract 1 from it and print it on the screen. And suppose we have one variable n, and I'm initializing it to value 1. Basically, this variable n depicts numbers from 1 to 10. Now here is the definition of the function odd. Inside this function, we have an if construct, and then immediately after that, we have return statement. What does this if construct says? If n is less than or equals to 10, then you will print n plus 1 on the screen. As odd function is going to handle odd numbers, so if suppose we encounter number 1, so it will print 2 on the screen, right? And after that, we increment the value of n so that it becomes an even number, and then we call an even function so that we can handle that number, right? And here is the definition of even function as well. The code of even function is exactly the same as the odd function, but there is one difference you can encounter over here. Instead of n plus 1, you have n minus 1. After this function, we have a main function, and inside this main function, we are calling odd function. Why we are calling odd function? Because the first number we encounter is 1, and it is an odd number. Therefore, we first have to call the odd function in order to handle that number, right? This is the output we are expecting. 2, 1, 4, 3, 6, 5, 8, 7, 10, 9. And now let me simulate this code with the help of stack. This is what we are doing usually, right? When we see recursive programs. Suppose we have a stack like this, and initially, as we know, main function is called. Inside the stack, the activation record of main function will be created, right? Which is denoted by act of M. Act simply means activation record. O means odd function. Whenever you find a symbol O, you should replace this with odd function. And whenever you find the symbol E, you should replace this with even function. Okay. M means main and act means activation record. So basically what does it mean is you are storing the activation record of this main function inside this stack. Okay. Now as inside this main function, you are calling the odd function. Therefore, the control transfers to the odd function and the activation record of the odd function will get stored inside the stack. As we have called the odd function, and inside this odd function, as you can see, we have an if construct where we are checking this condition is n less than or equals to 10. As n is initially 1 and 1 is less than 10, it is satisfied. Therefore, we come inside this if construct and we simply print value 2 on the screen, right? And then after that, we increment the value of n so that n becomes 2. And now we simply call even function. This means now the control transfers from odd function to even function and the activation record of even function will get stored inside the stack. Now inside this even function again, we encountered this if construct as n is again less than 10 because n is equals to 2 and 2 is less than 10. We go inside this if construct. We simply print value 1 on the screen because 2 minus 1 is 1, right? And then after that, we increment the value of n. Now n becomes 3. And then again we call odd function. Now control will again transfer to the odd function and the activation record of odd function will be created inside the stack. As value is 3 and 3 is less than 10, again condition is satisfied. We simply print value 4 on the screen and then we increment the value of n. Now n becomes 4 and we simply call even function. Now the control transfers from odd function to even function and the activation record of even function is maintained inside the stack. As n is equals to 4 and 4 is less than 10, condition is satisfied. We come inside the if construct and here we will simply print value 3 because 4 minus 1 is 3, right? And then after that you increment the value of n. Now n becomes 5 and we again call the odd function. And the activation record of odd function is also maintained inside the stack, right? Now when n is equals to 5, we print value 6 on the screen, right? And then again value is incremented and even function is called. This process will continue like this way only until and unless we obtain n equals to 11. When we encounter n equals to 11, the condition itself fails and we start returning, right? Now suppose after this point, we are returning. As return means, you will return back to the position where you left off, right? As we are returning from the odd function, the activation record of odd function will get popped out of the stack and we return back to the even function where we left off at this point, right? After this, there is nothing. You have encountered return statement again. This means you will return back to the position where you left off, means you will return back to the odd function at this particular point. And again, after that, you find return. This means you again return back to the even function. And similarly, the procedure continues. You are simply returning back. Finally, you encountered the main function. And as you can see, after this point, there is nothing written. This means this main function will simply pop out of the stack and the execution is completed. Now let me execute this code for you and check whether this output, whatever we are expecting, is what we are getting or not. Here is the code which we have seen already. We have an odd function and an even function. And after that, we have a main function. And here we are calling an odd function. Let's see whether this code works fine or not. Yes, it produces the output 2, 1, 4, 3, 6, 5, 8, 7, 10, 9, which is the expected output. Okay, friends, this is it for now. Thank you for watching this presentation.
Okay, so that's mutual recursion, or you call that, another name for it is the indirect recursion. Again, if you watch the video carefully, it happens when method A calls method B, so interchangeably, until the conditions are satisfied in both the methods which are being called, A and B. Okay. For this one, it says that it is difficult to understand and trace, but on certain certain situation it happens naturally, means it is like after one method being called and then it's automatically goes to the next one in order to satisfy what argument it has. Okay, so this one is the illustration of what we have seen just in the video. Yeah, this one. Method A being called, method B being called, and then it goes back and forth. Okay, it goes back and forth until it reaches towards the end where all the values are being returned. Okay, see, notice the arrows goes and settles out. Okay, to settling all the expressions, and then it goes back again until it returns to the main argument. Okay, and then pop out from the stack. So the example just now which we have seen shown you in the video is the slip video is the using C. Yeah, the same concept applies if you're to use Java as well. Okay, so this is mutual recursion or indirect. Okay, so next one is the question whether which one do you choose, iteration or recursion. Okay, so there are two ways to solve a problem. Okay, as you can see, I mentioned iteration and recursion, and then deciding whether you want to select iteration or recursion in your program execution is also based on certain conditions. So the factors which you are supposed to consider is the nature of the problem. Okay, nature of the problems, which refers to the time which is required to solve the problem, meaning if you are having time constraints, so therefore you are supposed to select which is having less time in processing. And another one is which one is more efficient than the other. Okay, so that is explained here. If time complexity is the point of focus, that means if you are, looking at time, meaning you want shorter time to process, to execute the transaction. Therefore, you have to maybe select recursive because, if time complexity is the point of focus, therefore, and number of recursive calls would be large, so you use iteration. Because if you were to use recursion would need a lot of time. If you can call back the video, if you process or execute a program based on recursive algorithm, it requires a lot of time to execute because you have recursive calling functions within the functions of itself, until it reaches incremental value to reach a certain point where your desired solution or problem is solved by that particular result. Okay. However, if time complexity is not an issue, so you don't care about how long or to wait for the transaction to be executed, and therefore, because of its shortness of code, recursion can be is best to be selected. That this is the conditions. Next one, an iteration does not use the stack, so it's faster than recursion. Therefore, it consumes less memory. And then, but iteration makes the code longer. So based on this criteria, you make your selection whether you want to use iteration or recursion accordingly. Yeah. So if you want it to be faster in terms of transaction or executing of codes, therefore you choose iteration. Yeah. So recursion, on the other hand, is made for solving problems that can be broken into smaller, repetitive problems. So it says here it's especially good for working on things that has many possible branches when you want to solve problems that are too complex for iterative approach. So one good example here says that you could apply this when you're trying to search through a file system, or you want to search through something in the search engine. For example, if one for file system that are kept in the subfolders of each of the folders which you have in your, for example, in your computer. Okay, so this one, the most suitable one that to be used would be recursion, it says here. Okay, so this is how you decide which one of these, iteration or recursion, that you need to select based on these factors. So this I took the initiative to provide the iteration versus recursive comparison, so that just to give you an idea how it functions for each recursion and iteration. So the basis for comparison is specified from the basic format, termination, conditions of each of this, infinite repetition, applied stack overhead, speed, and size of code. So based on this detail, okay, you are able to make decisions on which particular algorithm or program for your program, algorithm for your program to be used. Either you want to use recursion or iteration. Okay, so you can read on that one, right? This is a comparison. Okay, this one is a further a discussion on recursive solution. Just repetitive, but let's just go through this quickly. When method is called, memory space for its formal parameters and local variable is allocated. Okay, so when the method terminates, obviously your memory space is also deallocate and free the memory. This means that every recursive call requires the system to allocate memory space for its formal parameters. So if there is a long haul of codes that you need to execute, or variables, arguments, okay, therefore that you need more space of memory. But once that is completed, okay, each of the execution, then therefore immediately if you were to refer to stack operation, it will automatically be deallocated to free up memory space. Okay, so then there is a problem of if there were usage of a lot of space for your execution of recursive, therefore this is overhead. There is an overhead associated with executing this recursive method in both terms of memory space and computer time. So that also quite expensive if you were to use this kind of method. Okay, therefore a recursive method executes more slowly because it requires execution of many arguments which you state recursive, right? It is trying to find smaller calling of its own function until it reaches into a certain stage where it fulfills the argument which are stated in the case, recursive case. Yeah. So therefore, a recursive method is easier execute more slowly than its iterative counterpart. As simple as that. Okay, now this is another issue, but in today's computer, okay, this is just trying to solve the issues of if you are, having time constraint or memory constraint. But therefore nowadays our computer has fast and have inexpensive memory. Okay, meaning we have, more specs which is catering to this kind of facility, yeah, to enable you to compute fast and have a lot of memory in your system. So therefore, if this is not an issue, your recursive method can be selected. There's no problem with that. Okay, so keeping the power of today's computer in mind, the choice between basically two alternatives, whether or not you want to execute and implement recursion or iteration, is depending on the nature of the problem which you're trying to solve. So it's all about the problems, not if you want to, you don't mind about having slower processing time, or or that it is required memory space. So because of nowadays our computer are getting more and more advanced, so that should not be a problem. Then therefore you should just focus on what kind of problems or nature of the problem they're trying to solve. Okay. So also you need to see which particular method that computes and give more efficient settling of issues that you are trying to solve. That is going to basically influence your decision whether or not you want to select iteration or recursive method. Okay. So as general rule, if you think that an iterative solution is more obvious and easier to understand than the counterpart, which is recursive, use iterative solution. Okay, it says because it is more efficient. Yes. So on the other hand, again, if the problem exists for which the recursive solution is easier to construct, regardless of memory space and also processing of the execution of the memory, which involved as well. Okay, fast processing, slower processing. Okay, I mean, and then keeping the power of recursion in mind, the definition of a problem is inherently recursive. Then, therefore, you should consider recursive solution. So it's all about the situation which you have to face when you're trying to solve a problem. Okay, so if memory and speed are not of concern, therefore you should choose which one is suitable to the situation that you're trying to handle. Okay, as simple as that. So these are your references. Therefore, to conclude on this lecture, you should be able to describe what are the concept of recursion, describe the concept of recursion, and solve a problem using recursion. Okay, you have seen several problems which regards to recursion, this topic, and conduct or execute a trace a recursive method call. How do you do that? And analyze between the efficiency of two methods which regards to recursive and iterative solution. Okay, so these are the topics which we have covered for today. All right, so if you want to enhance your comprehension on this topic, later on, you could just refer to the notes again and play back that video. There are other solutions, there are other videos which are available as well. So you may select which is suitable to enhancing your comprehension. Okay, all right. So end of topic for today on lecture note recursive. So now what we can do is we want to go and see what you have done on your practical, which is referring to keeping track of which have you completed, which is referring to your practical material. Yeah, let's see. This one. Okay, this one. Yeah. Okay, so we are now under week 7. We should be going towards the recursive activity or practical question. Now let's see. Previous week, right? We have done on all these, except some of that we did not, we skipped. Yeah, this one we did. Some of it, which is also belongs to the same topic, we skip on that. And then we did this one. Yes, this is done. This one, array list, array implementation of collection entities. I need to check whether you guys did it. And then after that we have link implementation. We did this one, right? Did we? Yeah. Yes? Did I assign you guys that? Or I just assigned this?
Yeah.
Array. Did I assign the other one, practical number 5? No? This one. Yes? No?
Yeah. Good.
No? Okay.
Have.
Okay, for today, I will check. Yeah, I will check the GC whether I've assigned that one on the week 6. I think I assigned 6. Recursion have not, right? Maybe I assigned this one. I think this one I assigned. Let's see. Yeah, this one I think, right? Yeah. So I hope you have received or seen all the codes which I gave you, the sample codes, so you can refer to it as examples where you can implement and find solution for your problems. Okay, for today, there are many questions on recursion. Yeah. So 1, 2, 3, 4, 5. So I want you to select. We'll give you only 2, yeah, out of this. Number 1, let's see which one is suitable. Write a recursive method, count up, that display the count up from 1 to n, where n is a positive integer. Okay. Hint, a recursive call will occur before you display anything. Okay. This one you will have to refer to the lecture notes what it means, because there is 3 methods on how a method structure that you could follow, right? 1, 2, and 3. So this one, a hint, is referring to one of the method, the structure of the method that you could use. A recursive call will occur before you display anything. Okay, remember that? So this is your hint in solving this problem number 1. Number 2, write a recursive method that takes 2 integers and finds the greatest common divisor, GCD. Okay, greatest common divisor. Complete the extra challenge question in practical 2, question 1, if you have not done so. Okay, so question practical 2, question 1. What is practical 2? Question 1, which is on the top. Question 2, practical 1, isn't it? Is this one? What is the question? Write a recursive method that takes 2 integers and find the greatest common divisor. Complete the extra challenge question in practical 2, question 1. Okay, so therefore you need to refer to practical 2, question 1. That should be under week 2. Practical 2, question 1. Practical 2, question 1. Okay, so that is referring to practical 2, question 1. This one. Rational fractions are of form A or B, where A and B are integers and B not equals to 0. Write an additive specs to represent a fraction, include operation to set, and get the numerator and denominator, as well as to perform arithmetic operation, which is referring to addition, subtraction, multiplication, division. For the arithmetic operations, the current fraction is the first operand, whilst the second operand is passed as a parameter to the operation, and the resulting fraction should be returned. For part B and C below, write your code in the chapter 2 NetBeans project fraction folder. Okay, so questions, which is referring to recursive. I think we don't need to do that yet, because it is going to do with the connecting to the other one. Okay, that is question 1. Okay, you don't do that. All right, so maybe you can do write code to compare the performance of 3 different implementation of Fibonacci numbers using recursion, iteration, and array. Right, okay. So you can next one, write a recursive method, display backward, that writes a given array backward. Consider the last element of the array first. You may add your code to chapter 6. NetBeans project recursive display array class. Write a recursive method, count nodes that counts and returns the number of nodes in a chain of linked nodes. Yes, okay. All right, so what you can do, you select 2 from here. Okay, maybe select 1, the easiest, yes. The less complication that you need to refer back and forth. Maybe question 1 and question number 3. Okay, so for today, you do question 1 and question 3. Okay?
Okay.
So for this topic, practical 6 on recursion, you do question 1 and question 3. Yeah, easiest 3. So that you can focus on your assignment after that. As long as for today's topic you are able to practice what we learned, you've been about the Fibonacci, one of it, and also the count up. Yeah, yeah. So another one, is there any other things that you need to do here? Recursive, mhm. Okay, so you do 1 and 3, and if you find that 1 and 3 is too easy, maybe you can add up 5, yeah? Otherwise, you just do 1 and 3. Extra, you could add any 4 or 5, yeah? 1 and 3, if you want to add extra, you could add either 4 or 5, okay? Otherwise, just 1 and 3. This is just to get yourself challenge yourself whether you want to do extra or just to test that you know how to apply which method. Okay, so 1 and 3, if you want to try extra question, you could pick which one, either 4 and 5. Okay, so which 1 and 3 you want to attempt? Extra question to practice on recursive. You could choose between question 4 or question 5. Okay. Okay, there shouldn't be a problem, right? I think what else is the recursive display array? Where is that? Let's see whether I inserted that. Hmm, sample codes. Okay, wait. This is supposed to be on the sample code for chapter 7. Okay, so you have countdown. Yes, we have here countdown 2, countdown course, factorial, test factorial, recursive display array. Okay, so this is the one, right? Recursive display array. Test recursive linked display Java. Okay, so your example are all here. All right, so you can refer to that if you were to do the question. Okay, so you may attempt that, and then in the meantime, while you're attempting that, could we have a briefing? Like, could you brief me what is happening with your assignment?
Or no change.
Oh yeah, my progress also
No change.
haven't
What is the
progressed much.
progress?
Still at the UI and trying to add the stack, not trying to do the add list thing. Haven't finished that one.
List.
Like adding like the function to add the item group. I haven't finished that one also. Still in
Oh,
progress.
okay. So you see, when we actually doing all these lectures, it is also at the same time giving you options on which particular methods that you can use in your construction of your codes, right? So that's why each day, each week, we are actually learning something new, so that you can see which one is suitable to be implemented in your code as well. So you will have from chapter 1 until chapter 7 a whole bunch of extra sample codes that you can refer to as well. So slowly take the time to look into that code slowly, yeah, based on, and try to analyze what are the kind of problems, not question, problems that or issues that you are currently facing, and try to identify which particular method, okay, to be applied. Okay, there's so many um, ways on how you could solve your problem. So you just have to see which method is suitable, right? Okay, don't. Sometimes I know there are so many resources online, but you just pick one or two, make comparison. Okay, you don't have to uh, make it too complicated. Okay, so bear in mind, you should not copy and paste. You should get it as reference, and then based on that reference, you construct and apply what is in that particular code that you have found. Okay, so Noel, basically you showed me that solution, right? That video which gives solution to a problem which you can use. Yes, you may use that. It is not basically documented. You can still do some alteration based on what problem you have. Okay? So, references are not bounded by only documents. It can also refer to videos as your reference, right? Okay. So for
Okay.
now, I let you do the question for today's practical, which is question 1 and 3. And then after that, if you manage to do that, you can show it before the class ends. Yeah. Now it's 3. We ends at 4. Yeah, maybe about 3:30, like that. We can see what we have done on the code for practical questions 1 and 3. If you manage to solve that, yeah. Okay, so I'll check on you again at 3:30. Okay.
Okay.
recursive. Hang on a sec. Can you share?
This the count up.
Yeah.
Just count up until 10. So like this 1, 2, 3 until 10. If I change this to 5 or so, you can change. You can count up to 5. Yeah. This is all I need to do, right?
Yeah. Oops. You share it again. Let me see.
Oh. Yeah, so I just have one integer, and then it count until n only. It keep adding until n.
So hang on, yeah, cut up, yep. 5. That is you changing that value. If your integer is a is equivalent to 1, well, a is less than, if a equals to n, therefore what you do is you print out the value. Okay, so that if that is less than the value 5, then it will get printed, right? Can I see? Yeah. Okay. So therefore, if it is more, then can you set up the value to yeah, okay. If you want to change that, you probably can change on the you should probably change on the int, right? A equals to 1, that count up
Yeah,
to 5.
where I want to start, I can change the a.
10 equals to n. Yeah, okay. So sorry, I got this like disconnected. Yeah, can you hear me just now? The last one. Yeah. So can you do that change of the variable 5 again, please? Mm. Okay, excellent. All right, so all right, let's see. Question. Right, a recursive method count up that displays displays the count up from 1 to n, where n is a positive integer. Yes, a recursive call will occur before you display anything. Yeah. Okay, so as long as you can do that, right, printing out what the value is, then it's okay.
Does this count as recursive? Because I
And it's a positive integer. Recursive call will occur when you display. A recursive call will occur before you display anything. Oops, where am I? Okay. Hang on, yeah. Hang on a sec. Let me see my document here.
since I didn't use the n-1, so does this mean this doesn't count as recursive method?
there is a three conditions or method which you structure, if you can see inside our lecture note, right? So uh, you could actually hang on, you add n plus plus. Okay, wait a second. Yeah, let me just refer my document first. Yes. Okay. What was your question again? Sorry, Calvin.
Oh, does
Is
this
this a
out?
recursive?
Yeah, since I didn't use n-1 to do it.
But you have that a plus plus down there, right?
Oh, that one also count as recursive. Yeah.
Yeah, looking like that. Okay, wait a second. I just give you. I find that answer for this one, which is question. This is question 1, practical 7, right? Practical 7, right?
Practical 6.
Oh yeah. Okay, wait. Okay, that one is a display count, right? Count up, right?
Yeah.
So yeah, over here what I have is the display count. Your conditions which you put down there is, where's your condition? Second, yes, and less than count up to 20, public static count up, int a equals to 1, public static void count up, integer add, you have your add, if n more than 1, count up, n minus 1, yes, you have that as well. Oh, this is you set it up yourself, right? Public static void main string, print out does not, and count up 10, count up 3, 1, and 100. Okay, so how many count did you have? Let's see. You fulfill that count up problem, and then you count up to 20 from the static void count up, and it is specified as n, yes, and then you initiate your a define equals to 1, while a less than equals to n, then you print out a which is 1, a plus plus. So question here is, if n is more than 1, count up would be n minus 1. Yeah, I think this one should be okay. This. And then your print out would be count up 10, count up 3. Yeah, this one is also specifying the value by itself. And count up, yeah, yours is more shorter comparison to this one, which is good, right? Yeah, better, I think. Yeah, this one is okay.
The third question I haven't finished. I haven't done it.
Okay, submit this one, yeah?
Okay.
Yeah, but you only do one and then you create incrementally, which is good. And this one requires that a lot of printout going up to be setting up of that. Noel, what about yours? Okay, doing fine?
Okay. So this is for the question 1.
Mm-hmm. Can you explain your code?
So before the main method is execute, I put in the count up method, which takes the integer as the argument. So first, if the n equals to 1, then it prints out the
value.
Yeah, and return, or else it will run again the same method, count up, but this time it's n minus 1. Then after all, I mean, after this method is executed, then it print out the end. So if
Okay, can you run?
I change this to 10. So yeah, 1, 2, 3 until 10.
Mm.
Is
Yep,
that
excellent.
correct? Okay. But
Good.
my
Looks like you
question,
guys are, yeah, looks like you guys are able to find easier way to present your codes, and then to display what is required, which is excellent. Yeah. So public static void count up, integer a, almost the same, and then your argument will be n equals to y. If n is equal to 1, system up in line n. Then else count up, which is n minus 1, and then you print out that minus 1n. So you count up to 10, and then displays 1 until 10 based on that particular array. Okay, good. Then you submit this one straight away. Yeah. When you finish doing the the question, straight away submit. Yeah, so that you don't forget.
okay.
Right. Thank you. I'm raising my hand. Goodness. Okay, so now you can do 1, continue with 3. Okay, so keep up with doing your assignment. In our, I am in the process of handing over. Hang on, yeah, wait a second. Okay, I am in the process of handing over my task for this week to Mr. Jeffter Edward. If you notice in our Google Classroom over here, this is your new instructor, Mr. Jeffter. Yes, so he'll be taking over the tasks on week 8 onwards next week. Okay, so I will be adding him inside the Google WhatsApp group as well. So anytime you need questions to ask me, you can private message me or you can WhatsApp in there. Okay, if it is general question, otherwise you can private message me. Yeah, because Mr. Jafter is all, going to be added in. I will add him in the group so he can communicate with you and we know which progress and you know what we have with you guys, so that he knows what I'm doing with you guys, and then also I know what he's doing with you guys after that. Okay.
Okay.
So in the future, again, if you have questions still that you need to ask me about what I have left off with you for this week and the previous week before, anything about attendance, anything about the questions which regards to the lectures previously or any other things, even with your assignment, you are free to ask me anytime. Yeah. Yeah, and then of course for the next lecture you can ask Mr. Jeffter. Okay, so next week onwards online you'll be going with Mr. Jeffter, so I won't be online with you. This one will be a last session with you, I suppose. Yeah. So with that, before we conclude, I would like to ask the last question with you in online Google Classroom. Do you have any questions? And then what do you think of the lecture so far? Is it okay? Is it still confusing? You are still have a lot of issues that you cannot resolve?
The lecture, okay, just the assignment, very confusing.
Tough, right?
Yeah.
Actually, I'm just I feel like I want to share with you guys the answers. I have a lot of answers here, but it's just that what we were instructed is that we cannot give you. We just have to see what you're doing. If it is your whatever you do is okay, then we just advise you on how to uh, make changes. Otherwise, then we leave it to you to actually create your own creativity in solving the problem. Yeah, because usually they say if it is during examination, the questions which I gave you, I should not give you answers. Otherwise, they will, I don't know, they will give the same question during exam, and that will be cheating. It seems that you guys are cheating because you guys already have the answers. Yeah, so that very much like that. So I cannot show you guys the answers, unfortunately.
Oh,
So that's why if you have issues and you feel like you want me to confirm whether that answer is okay, you can ask me for previous lectures. Okay, uh, you can ask Mr. Jaffer for the preceding lectures. Okay, so that's all which I can actually assist you guys with. And if you have, I will be checking from now on. I'll be checking. I've checked some of it, but I haven't returned it to you. Your your practical questions. Um, so I will be returning and giving you. If you manage to do that, just get the result and all that. I'll just give you the full marks for that for all the practical. Okay, so again, uh, there is one question. There's a lot of questions which are posted, which is on theoretical on the coursework. Okay, so we should not be giving you the answers, but you should attempt that and see. That means to just check on you yourself on your understanding. Okay, that is under. Hang on, let's show you that. Yeah, show you that, which is. Is that practical question? Yes, this one. Very practical question. So if you notice, all of these questions I should not be sharing with you based on what is given in the red color. Yeah, yeah. So it says do not share your answers, which I should be not sharing it. If students happen to refer to weekly submission, and then that will be considered as cheating. So anyway, all this, chapter 5, 6, 7, and 8, that is to explain to you each of the content of our uh, lecture. So for example, this one, chapter 5, explain the steps that need to be carried out in a push and pop operation when a stack is implemented using link implementation with a reference to the top entry. What are the steps? Okay, that you should know. If you follow the lecture, you know what are the steps to be carried out if you want to push and pop operation. So basically, this question is theoretical. Okay, and then explain how a queue may be implemented using a link implementation with only one external reference to the last node. So this one could be a program or source program code, a source code, or an answer, right? So if you want to represent your answer both ways, also good. So if you feel like you want to attempt this and you want to check with me, you can WhatsApp me with question and I will guide you on which for before I entirely handing over to Mr. Jafter. Yeah. Okay.
okay.
Mhm. All right. So any more questions? If you have any questions, other questions?
So far,
How about you, Alvin?
Okay.
Okay. So if there's no questions for today, thank you for your attendance. I will mark and check accordingly if I have marked your attendance. Also, I'll be checking on all those things which I need to mark and give you and return to you one by one, starting this week and then until next week. Yeah. So by then, at the end of at least 2 weeks, then you should be already ready. Okay. I think ready for reference. I think you guys are okay. You guys can do better than the example which is given. You guys are quite creative, in my opinion, for your program. So there wouldn't be any problem if you were to been asked this question. Just need to be able to recall and then apply in your code, right? Because you managed to solve the problem, the issue just now in both different ways, both of you. So you should be able to execute some other questions. I don't feel that there is a problem. Okay, so thank you so much. I will see you on WhatsApp or email for the next uh, week after this. All right. I wish you good luck with Mr. Jeffter, and I'll see you when I see you.
okay.
Okay. Thank you, Miss.
Thank you.